Good morning, one and all. Today in this class, we are going to learn about very interesting topic that is physical properties of aldehydes and ketones. Physical properties of aldehydes and ketones. Yeah. Here, under the physical properties, first thing will be physical state. Physical state. In the case of aldehydes, formaldehyde HCHO is the formula. Formaldehyde is a gas, okay, and then the aldehydes which containing up to 11 carbon atoms are colorless volatile liquids. Aldehydes which containing up to 11 carbon atoms, 11 carbon atoms are all colorless colorless volatile liquids. Okay, then the aldehydes which containing more than 11 carbon atoms. Okay, and the aldehydes which containing more than more than 11 carbon atoms are all solids. Are all solids. Clear? Next, in the case of ketones, in the case of ketones. The ketones in which they containing up to 9 carbon atoms. Up to 9 carbon atoms are all colorless volatile liquids. Okay. The ketones which containing up to 9 carbon atoms. 9 carbon atoms are all colorless colorless volatile liquids. Colorless volatile liquids. Clear? And remaining all are and remaining all are solids. Clear? Okay. In the case of aldehydes, formaldehyde is a gas. Okay, formaldehyde is a gas, and remaining aldehydes which containing up to 11 carbon atoms. Okay, up to 11 carbon atoms are all colorless volatile liquids. Okay, it will evaporate easily at the room temperature. And the aldehydes which containing more than 11 carbon atoms are all solids. Clear? Next. And in the case of ketones, the ketones which containing the carbon atoms up to 9 means the compound which containing 3 carbon atom, 4, 5, 6, 7 up to 9 carbon atoms are all colorless volatile liquids in the case of ketones. And remaining all are solids. And the remaining all are solids. Clear? Next one is odor. Carbonyl compounds are exhibit unpleasant sharp odor. Carbonyl compounds carbonyl compounds are exhibit unpleasant sharp odor. Exhibit unpleasant unpleasant sharp odor. Unpleasant sharp odor. Clear? And if the number of carbon atoms increases, the unpleasant becomes pleasant odor. Okay. If the number of carbon atoms, if the number of carbon atoms increases, unpleasant becomes, unpleasant becomes, okay, unpleasant becomes pleasant odor, unpleasant becomes pleasant odor. Clear? If the number of carbon atom increases, unpleasant odor becomes pleasant odor. Okay, therefore, and therefore, therefore, carbonyl compounds are used in fragments. Used in fragments. Clear? Next. Third one is solubility. Third one is solubility. Carbonyl compounds, carbonyl compounds are are readily soluble in, are readily soluble in benzene, carbon tetrachloride, that is CCl4, and carbon disulfide, and carbon disulfide. And the carbonyl compounds which containing less than 4 carbon atoms. The carbonyl compounds which containing less than, carbonyl compounds which containing less than 4 carbon atoms. Okay, are soluble in, are soluble in water. The carbonyl compounds which containing less than 4 carbon atoms are soluble in water. Clear? Boiling point. Boiling point. Boiling point. Okay. When compared to, okay, when compared to alcohols, when compared to alcohols, carbonyl compounds, carbonyl compounds are having, when compared to alcohols, carbonyl compounds are having less boiling point, less boiling point. Why? Because because alcohols, okay, alcohols can form, alcohols can form intermolecular, that is intermolecular hydrogen bonding. Clear? See here, when compared to alcohols, carbonyl compounds are having less boiling points because carbonyl compounds are having less boiling point because alcohols can form intermolecular, they can form intermolecular hydrogen bonding. Clear? And when compared to ether and alkanes, when compared to ether and alkanes, carbonyl compounds are having, are having, carbonyl compounds are having more boiling points. More boiling point. Why? Because because Presence of because carbonyl compounds present dipole dipole interaction. Dipole dipole interaction. Dipole dipole interaction. See, when compared to ether and alkanes, carbonyl compounds are having more boiling point. Carbonyl compounds are having more boiling point because carbonyl compounds present dipole dipole interaction. Carbonyl compounds will present dipole dipole interaction. Clear? Okay. And now the order of the order of the order of these compounds such as alcohol, okay, alcohols is greater than alcohols is greater than carbonyl compounds is greater than ether that is greater than alkanes. Okay, this is the order of the boiling points of alcohols, carbonyl compounds, ether, and alkanes. Okay, for example, in the case of alcohols, we can add methanol. Okay, methanol is greater than methanol is greater than carbonyl compound. For example, ethylaldehyde. Okay, ethylaldehyde that is greater than ether. That is CH3OCH3 is the ether that is greater than alkenes. For example, CH3 single bond CH3 that is ethane. Clear? Methanol having the more boiling point when compared to ethylaldehyde. Ethylaldehyde is having more boiling point when compared to dimethyl ether, and dimethyl ether having more boiling point when compared to ethane. When compared to ethane. Clear? Okay, thank you.